Okay, so today we're going to kind of take a step back here and we're just going to get some review of the trig ratios on the Cartesian grid. This is the stuff that we've been working on in the last couple of days. There were some really weird concepts that I threw at you the last couple of days. I want to make sure that we can stop in and focus on them and make sure we master them before we move on. So today's plan is we're just going to have a practice-based lesson today. It's not in the note booklet. I think I'll print some notes off for you guys today, just the slides from this. If I don't, unfortunately, that just means you'll have to copy these questions down in your notes. Not the end of the world, though. There's not all that many. We're going to start by reviewing trig ratios on the Cartesian plane. Remember, we use reference angles to do that. A reference angle is just an angle measurement above or below the nearest x-axis. We'll get into that when we get into that. We'll review the cast rule, which, in case you've forgotten, that just basically tells you whether you're positive or negative in certain quadrants, whether you're using sine, cosine, or tan. Then we'll review special triangles, which was its own really weird thing. We'll get into that when we get into that. And then I'll give you guys lots of practice time today, including your homework assignment for this unit, which you should have a good amount of time to plug away at today. And I do encourage you guys to work together on those. Anyway, let's get started. Here we go. So first things first, angles given an exact value. So suppose we know that tan theta, we don't know what theta is, of course, but tan theta equals 0.75. To the nearest tenth, determine the measure or measures, hint, hint, of theta. Now here's another big hint. We want to use the cast rule to figure which quadrants we're in. I recommend that we pause the video right here and I want you to work either on your own or with a partner to see if you can figure out what the measure or measures of theta are. So pause the video here, give this one a try. All right, I'm going to go over this one now. So remember, if we're trying to solve for a theta, when we have tan theta or sine theta or cos theta, and it's equal to some number, you can quite simply take inverse sine or inverse cos or inverse tan, in this case, to find what that angle is. But the kind of weird thing is you can have a number that appears in one quadrant that also appears in another quadrant. So let me show you what I mean. First things first, take inverse tan, I'll even write it out, inverse tan negative 1 of 0.75. Because what we're really doing is we're taking inverse tan of both sides of the equation here. Inverse tan of tan just knocks it out, so we're just left with theta, right? So theta equals the inverse tan of 0.75. Also, make sure you're in degree mode for this. I don't know any reason why you wouldn't have been after the last couple of days, but just in case. Inverse tan of this to the nearest tenth should be 36.9 degrees. That's all well and good, but we want to use the cast rule, of course, just to make sure we're in the proper quadrants here. Just to remind you what the cast rule is, if we drew our 4 quadrants, the cast rule starts down here and it goes this way, C-A-S-T. And what this tells us is where we're going to have different trig ratios be positive or negative. So notice tan theta was positive. And since tan is positive here, that means we're either in this quadrant or we're in this quadrant. Remember, A stands for all. It just means all of them are positive up there. Since it didn't tell us what quadrant we're in, we actually have to assume that there's 2 different measurements of theta in each of these, like one in each of these quadrants, right? Now, the nice thing is the all quadrant is your default. So that's between 0 and 90 degrees. So this answer that we got here of 36.9 degrees, that is our quadrant 1 answer. So that actually is one of our 2 answers there. But there's something weird here as well. We could also be, of course, down in the T quadrant, quadrant 3. It is totally possible for tan to be a positive number down in quadrant 3. And that's going to have an angle somewhere between 180 degrees and 270 degrees. We got to find out what that angle would be. And here's the good news. When you take that inverse tan and you get that number, that not only is your quadrant 1 answer, but that is also what we would call a reference angle. So in other words, that is your angle below the x-axis for the quadrant you're interested in. Long story short, to determine what our other possible angle would be is to take this answer of 36.9 degrees and simply add it, because we're going further up from 180, just simply add it to 180. So 180 plus 36.9. And I just want to be totally sure, so I'll throw in my calculator as silly as it seems. Yeah, it's 216.9 degrees. That is our quadrant 3 answer. So those are our possible measurements of theta, such that tan theta equals 0.75. If you don't believe me, you can always test this answer quite simply. You can say tan of 36.9 and throw that in your calculator. Now, of course, because we rounded this, it's not going to be perfect, but you're going to see it is approximately 0.75. And then you can also test tan 216.9. And again, we just rounded that. So if you test it, it's going to be close, but not perfect, but it is approximately 0.75. And both of those, should note, both of them are indeed positive. Okay, kind of weird, but just remember when we're looking for an angle measurement, you just use inverse sine or inverse cos or inverse tan. Just be really careful though, because if it didn't tell you what quadrant you're in, if it's positive, it could be in one of these two quadrants. If it was negative, it could be in a different quadrant. And it all depends on whether I gave you sine, cos, or tan to begin with. Let's do another one. This next one's a little trickier, but it's similar. Suppose we know that sine theta equals negative 0.88. I was almost going to say degrees, but negative 0.88 is what you got, right? To the nearest tenth, determine the measure or measures of theta. This is very, very similar to that last question we just did, but I have an additional hint for you this time. Remember, never use inverse trig on a negative number. You can just turn it to positive and then use your cast rule. Anyway, I want you to work either on your own or with a partner. Pause the video here and give it a try. All right, I'm going to go over this one now. That hint is really, really crucial. Never, ever, ever use inverse trig on a negative number. You can do it, but it's going to give you an answer that might not lead you in the right way. I recommend, for the sake of convenience, turning the number into a positive and then using inverse trig. So let's try using inverse sine on positive 0.88. If I throw that in my calculator, inverse sine positive 0.88, to the nearest tenth, I get 61.6 degrees. Now, that is just a reference angle, just like what we had before, right? It's just a reference angle. That's just going to serve as a pointer as to where we need to be. Let's use our cast rule, however, to figure out what quadrant or quadrants we possibly are in. So drawing out our cast rule here, C-A-S-T, we want the quadrants in which sine is negative. Well, notice sine is positive in the all and the sine quadrants, so we're not going to be up there. So that means we're either in this quadrant down here or this quadrant down here. Remember that this quadrant in the bottom left here is between 180 and 270. And this one over here is between 270 and 360. So we know our answer, or answers, I should say, are going to fall in those ranges. Let's use this reference angle we calculated to get those answers. In quadrant 3, that's the T quadrant. In quadrant 3, we're just going to take 180 and we're going to increase it by 61.6 degrees, our reference angle. So 180 plus 61.6 should give us 241.6 degrees. That is going to be one of our measures of theta. In quadrant 4, that's the C quadrant. Remember, a reference angle is based around your x-axis, not based around your y-axis. So we're going to have to take this 360 degrees and take away our reference angle to come down from it. So 360 minus 61.6. So 360 minus 61.6, that should give us 298.4 degrees. So that would be your other answer here. Just like the last one, it's redundant. You don't have to do this, but just like the last one, you can test your answers by just going sine 241.6 and throwing that in your calculator. And it should give us pretty darn close. It gives us very close to negative 0.88. Negative 0.88, sorry. Negative 0.88 is really close to what it gives us. So we can say that one's pretty much confirmed. So that's good. And if you want to check the other one just for good measure, sine of 298.4. Throw that in your calculator. I'll do it just now just to be sure. Yeah, it also gives us a number really, really close. I should do the little wiggly wavy waves here. Negative 0.88, really, really close. So we know we've got it, right? That is a useful way of checking your work. Some people often try to use this 270 and add things on it. I've seen it before. That'll give you a wrong answer. And if you check your work, you'll catch that and make sure that you correct it before you go any further. Okay? Bottom line is here, if you're asked to find for a measure of theta, use inverse trig. Just be really careful that you use inverse trig only on a positive number, and then also be careful to consider that you'll have two answers within your quadrant unless we told you otherwise. Anyway, moving on. So this isn't a question, just a reminder. Remember, we talked last class about special triangles. These are triangles that you have relations that are known. They exist in 30, 60, 90 triangles and 45, 45, 90 triangles. They're on your formula sheet. So the bottom line is, if you ever see a 30, 60, or 45-degree reference angle, you can use sine, cos, or tan and get the relations with the opposite, adjacent, and hypotenuse sides instantly, right? Just pay attention to what's on your formula sheet, right? So this is useful when we know the reference angle, but not a specific point that it passes through. So if I just told you you had some angle and asked you for a sine, cos, or tan ratio, which needs side lengths, and I didn't tell you side lengths, you go to your special triangles and they're going to save your life on this one, right? These become absolutely essential in Math 30-1. I know that is not a concern for us right now, but it is just useful to let you know that this isn't just some stupid thing we learn once and then drop it. This does come back around at some point. Anyway, let's try this example. Find the exact value of cosine 315 degrees. An exact value basically just means we know cosine of an angle is adjacent over hypotenuse. Find what that value is. Find the value of that fraction, but we want it exact, so we are not going to use our calculator to get some weird decimal. We want it exact. Work with someone here, pause the video here, see if you can figure out a way that this relates to a special triangle. Anyway, I'm going to go over this one now. If you weren't able to get it, if you guys are really like, what on earth is going on? I don't blame you. Special triangles are a pain. I would personally start by drawing 350 degrees. So 315 degrees right here. We know 270 is there and 360 is over here. So 315 is probably right in between that. I'd say it's about right there. Now, the only angles that we really care about in this unit is the reference angles, because reference angles allow us to make a right triangle. The reference angle in this case from 315 degrees is just the difference between 360 and 315. The difference between those is 45 degrees. And remember, when you hear 30, 60, or 45, there should be a little bell, ding, 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 that goes on in your head. That's a special triangle. So we were given 315 degrees as being our angle, but we weren't told it's passing through any given point. So we have to use our special triangles to allow us to complete this triangle and get some sort of relation going. Because remember, cosine is adjacent over hypotenuse. So if we can find our adjacent side, and if we can find our hypotenuse, we're golden. I'm going to draw this just a little bit bigger because I realized that was maybe a little bit too tight to draw all this. So this will be our 315 degree angle. And we know that's a reference angle of 45 degrees. If we go back to our special triangles, you'll see in a 45, 45, 90 triangle, the side opposite and adjacent from 45 is 1, and your hypotenuse has a length of square root 2. So if we go back to what we drew here, the opposite and adjacent sides are 1, and the hypotenuse is square root 2. Now, we won't really care about this opposite side because remember, cosine is adjacent over hypotenuse, but just for the sake of reference, just so you're not like calling me out on this, if anyone's keen enough already to notice this, and if you're not, I don't blame you. But notice this 1 on the opposite side is downwards. Technically, that should be a -1, right? If you didn't fill in, it's not the end of the world because we don't care about the opposite side in this example. If this was sine 315 degrees, you better believe we would. But even if we didn't catch it, we would know cast rule would save us. Anyway, I don't have to go into that. So what we can say now is since we know our side lengths, and 45 degrees is just our reference angle, it just serves as a key, we can therefore say cosine of 315, which functionally is the same thing as the 45 degree reference angle here. Cosine of 315 is going to be your adjacent side, which is 1, over your hypotenuse, which is square root 2. Now, just as a bit of a fail-safe, it's always important to remember the cast rule, C-A-S-T. We're dealing with cosine. Should cosine be positive or negative down here? Well, it's in the C quadrant, so it should be positive. So the fact that this is positive 1 over root 2 is golden. We're great. So that is our exact value. That's our fraction right there. We nailed it, right? I didn't even give you any side lengths. You just used a reference angle and special triangles to get there. Again, just like the previous examples, you can test this answer, right? So we want to say that that's an exact value of it. If you use your calculator and go cosine 315, you get some really gross decimal. It looks like 0.707 blah, blah, blah. If you now go 1 divided by square root 2, you'll see it's the exact same number, 0.707, and then a whole bunch of other stuff, right? That proves we were able to find an exact value. As you guys can tell, this unit's really weird, right? There's a lot of really technical things that aren't very specific with what they're looking for. But as you do enough questions, as you start seeing it, it'll become a lot easier. And I know a lot of you hate hearing that because it just means, hey, you got to practice it to get better. welcome to life, though. That's just how it works. All right, I think this is our last question today. Yes, it is. It's our last question today here. So angles given an exact value. So we're going to kind of go the other way around now. Suppose we know that sine theta equals -1/2. Find the measure or measures of theta. Pause the video here. See if you can give this one a try either on your own or with a partner. All right, I'm going to go over this one now. This one was kind of a funny curveball. Really, this question is no different than the two questions I think we started with today. We did a tan one and then we did a negative sine. This is pretty much identical to that negative sine question. Two different ways you could do this. If you're really keen, and I wouldn't blame you if you didn't see this, because I'll be honest, I wouldn't have done this, but if you're really keen, you might have noticed that 1/2, an opposite over a hypotenuse, that could be considered like part of special triangles. If you didn't notice that, I don't blame you. That would be pretty tough. Instead, what I would do is I just say, okay, let's just turn this question into sine theta equals -1/2. Well, that's just -0.5, right? This now suddenly looks very much like that question we just did a few minutes ago. Remember, we never take inverse sine or inverse cos or inverse tan on a negative number. So let's just pretend that this is positive, and let's take inverse sine of +0.5. If you take inverse sine of +0.5, you're going to get a very nice smooth number that happens to be 30 degrees. Ding, 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 right? It was a reference or a special triangle angle. But now that we've calculated it, we don't even need to worry about that, right? So 30 degrees, that is going to serve as our reference angle in this case. And it just so happened to be part of a special triangle. Now, remember that 30 degrees is all well and good, but notice that sine was a negative number. If we return to our cast rule, let's see where sine would be negative. Well, it won't be in the all quadrant and it won't be in the sine quadrant. So sine is negative down here and sine is negative down here. We know 30 degrees is our reference angle, so we can just use that reference angle to find our true principal angle in those other two quadrants. Let's start with quadrant 3, the T quadrant, right? Quadrant 3, remember, is between 180 and 270, so we need an answer in between those. Our reference angle always comes down from the x-axis, so we'll take 180 and we'll add 30 degrees to it. That's going to give us 210 degrees as our angle that theta could be here. In quadrant 4, however, we're also going to come down from our x-axis. Our x-axis here would be 360. If we go 360, we'll actually have to take away 30 because we want to be between that and 270. We'll take away that 30-degree reference angle, and you're going to have 330 degrees as your answer. That's it. Those are our measures of theta. We found those two measures. And just like I've been kind of beaten to death today, if you ever want to check these answers, just check them by going sine 210. Sine 210, I'll even check it on my calculator just for good measure. Yep, it gives me -0.5. You can also check the other one, sine 330. I'll check that one as well, just for good measure. And yep, it also gives me -0.5. So in other words, we can easily check to make sure that we've got the correct answers here. We found the proper measures of theta such that sine of that theta gives us -1/2, -1/2. Anyway, hopefully that helped a little bit today. I know it was only a little small handful of questions. You guys really need to get practice on this. I did not want to move on today, so that's why I've kind of delayed this. But there should be a chapter 2 trigonometry assignment printed, hopefully for you. It is due next week. I don't remember what date. Don't worry about it. I think I wrote it on the board, but that might end up changing. We'll have to wait and see. You guys can do up to question 5 right now. That includes question number 5. Please make sure you guys are reaching out to one another. You can also reach out to me over Reminder Google Classroom if you need any help. And if for whatever reason you want some extra questions to practice, or if for whatever reason you didn't get the trig assignment, page 96, questions 1 to 9 are also a possibility for you. Anyway, best of luck. Make sure you reach out if you need help, and see you next time.